All right, so we're going to go over the inverse of trig ratios today. Okay, so yesterday we just went over what our trig ratios are. Today we're going to go over the inverse of those. So if I have tangent of 30 degrees is about 0.58, then it follows that if the tangent of an acute angle is 0.58, then that angle measure has to be 30 degrees. So what we're doing with the inverse today is actually finding the angle measure instead of the side measure. Okay, so we use this inverse to find an angle measure, not a side. So the inverse of a trig ratio is finding the angle measure given that trig ratio. So most of you will use the second or shift key on your calculator for the inverse function. Okay, so second or shift key. Okay, to find the measure of the angle. Okay, so we have our inverses laid out here below. So I have sine of A equals X, cosine of A equals X, and tangent of A equals X. To find that letter A, because we have to find the angle with it, we need to bring in this inverse. So this is what your inverse looks like. It has that little -1 there. Okay, that doesn't mean it's raised to the power of -1. That actually refers to the inverse of a function. Okay, so that's what that notation looks like. So how we solve that, if I have sine of A equals X. I want A by itself. Now remember yesterday I said you can't just divide by sine, you can't just divide by cosine or divide by tangent. Okay, you always have to have that angle attached to it. Okay, it's one number itself. So what we do is bring in the inverse to both sides of the equation. Okay, so I bring in this sine inverse to both sides of the equation. That way it cancels out on the left-hand side. Okay, so that's where they're getting this A value is equal to the sine inverse of X. Okay, so that's all we have to do to solve for that angle then. So we are going to do some examples, and I think you'll understand a little bit better once I do that. So we want to find the indicated angle measure here, and I won't go up too fast. So number one, we want to find angle A. So whenever I'm trying to find an angle, again, I always circle my angle just so I know which angle I'm going from. Okay, from there, I want to label my sides just like we did yesterday. So I have a side of 27 and a side of 18. Okay, so that side of 18, from my angle A, I have to go across the triangle to get to. So that I would label as my opposite side. Okay, then the side of 27 is across from your right angle, so that is always the hypotenuse. Okay, so we're going to look at SOHCAHTOA again today. So just rewriting that on your note sheet here so you can use it. In my first problem, right now, I have O and H. Okay, if I have O and H, that's this first one right here. That SO piece, meaning I need to use sine. Okay, so I'm going to use the sine of the angle I went from. Okay, that's your variable, so I'm going to write angle A. Okay, that's equal to your ratio of sides. Okay, your ratio of sides here, and so is O over H. Okay, so my O value is 18. Over my H value is 27. Okay, now I'm not multiplying or dividing anything this time. I want to get A by itself. Right now it has a sign attached to it. So to get A by itself, we bring in the inverse to both sides of your equation. Okay, so it cancels out the other sign on the left-hand side. So we just have A is equal to sine inverse of 18 over 27. Okay, and that's what we're going to enter into our calculator. So if you have your calculator, All right, so to get sine inverse, you have to press your second or shift key. You'll notice it's typed onto your calculator right above sine. Okay, so you can see that. So when you press second and then sine, your inverse should pop up. So that should say sine inverse, and then all you have to type in is your fraction here. So 18 divided by 27. And then press equals. Okay, so in this case, my angle measure is going to be equal to 41.8. Okay, so for the measure of angle A up here in my blank space, I have 41.8 degrees. Questions? If you have the backwards calculator, does anybody have the backwards calculator? You have to take 18 divided by 27 and press equals and then second sign. Did you get it? Okay. Anybody else have a calculator they don't know how to use or find it? I can help you. All right, we'll do another example here. So number 2, we want to solve for angle B. So I'm going to look at angle B. That's the angle I need to go from, so I'm going to circle it so that I can label my sides according to that angle. Okay, so I have a side of 6 and a side of 20. Okay, if I'm going from angle B, that side of 20, I have to go across to get to it. So I would label that as my opposite side. Okay, it is opposite that angle. My other side is next to my angle, and it's not the hypotenuse, so that must be the adjacent side. Okay, so here I have O and A. So looking at SOHCAHTOA here, the one that has O and A is this TOA piece. That means I'm using tangent. Okay, so I have tangent of B. That's equal to our ratio of sides, O over A, so 20 over 6. Now if I want my angle by itself, I have to bring in that inverse. So I bring in tangent inverse this time to both sides of my equation so that it cancels it out on the left. So B will be equal to tangent inverse of 20 over 6. Okay, make sure you can enter that into your calculator. You should get 73.3 degrees. So make sure you entered that correctly. Questions on number 2? All right, I want you to try number 3 then. Okay, you're finding angle A in number 3. Okay, finding angle A in number 3. All right, for number 3, which trig ratio do I use? Sine, cosine, or tangent? Cosine. Good job. Okay, so I have cosine of A will be equal to 3 over 15. Okay, so you should have A is equal to the cosine inverse of 3 over 15. Yes, I skipped a step. Okay, from there you just plug that into your calculator and you should have gotten 78.5 degrees. Okay, 78.5 degrees. I do, for quizzes and tests, I do at least want you to write out this step. So if you understand what's going on without writing that first step out, that's fine. But I do want you to write out at least this step right here where it says cosine inverse, so I know what your thinking was. Okay, don't just type it into your calculator without writing anything down, because if you do get it wrong, then you're going to get the whole thing wrong, and you won't get partial credit for it. Make sense? All right. Any questions on these 3 problems before we move on? All right, then. We now have enough formulas and information to solve a right triangle. Okay, so what that means is you're finding all of the angle measures and all of the side measures of a triangle. Okay, so all 3 sides and all 3 angles. So we are going to solve this right triangle in number 4. So that means we want to find all 3 angles, all 3 sides. So we want to find the measure of angle X, we want to find the measure of angle Z, and we want to find the measure of angle Y. For our sides, we want to find the measure of XZ, we want to find the measure of ZY, and the measure of XY, or YX. Now we already have 1 angle and 2 sides in this triangle. So I can write out those measures right away in my table here. So the measure of angle Z I know is 90 degrees. The length of XZ is 5, and the length of ZY is 9. Okay, so when solving a right triangle, we can use trig ratios, what we did yesterday. We can use the inverse of trig ratios, what we just did on the front, and we can use the Pythagorean theorem. Okay, so you have to decide what you want to use to solve for sides and angles. So first thing that I'm going to do, I want to find my hypotenuse. Okay, I already have 2 lengths of that right triangle, so I can use the Pythagorean theorem to find that final side there. Okay, so I can use a squared plus b squared equals c squared. My a and b values are 5 and 9. So I have 5 squared plus 9 squared equals c squared, which is 25 plus 81. That is 106. And I am going to round for this. You don't need to keep it in a square root. So I'm going to take the square root of both sides to get that final side in my triangle to be about 10.3. Okay, now I labeled that side C. That side was X, Y. Okay, so in my table now, that side X, Y would be 10.3. Okay, so now I have all my sides. Now I'm still missing my 2 angles. Well, we just learned how to find an angle of a right triangle on the front. Okay, we have to use the inverse of trig ratios. So which angle do you want to solve for first, X or Y? Doesn't matter. I'll just do X because I heard that one first. Okay, so I'm going to solve for angle X. So I'm going to use my 2 sides that I'm given here, this side of 5 and this side of 9. Okay, well that side of 9 is across from the angle I'm looking for. So that would be your opposite side. And this side of 5 is next to the angle I'm looking at, so that would be adjacent. So which trig ratio should I use? Tangent, good. Okay, so I'm going to use the tangent of my angle x is equal to, our opposite side is 9 over the adjacent side is 5. And I want x by itself, that's the angle. Whenever you're solving for an angle, you always bring in the inverse. Okay, so I'll bring in tangent inverse to cancel it out on the left. So we have x is equal to tangent inverse of 9 over 5. And you can just plug that into your calculator. And you should get that angle x to be about 60.9 degrees. What was that? Yes. So for the other angle y, you could do it two different ways. First way, long way, you can use an inverse again. Okay? So if you went from y right here, this side would now be your opposite, and this side would be your adjacent. Okay, so you can still use that inverse. However, all three of your angles have to add to 180 in a triangle. Okay, so all three angles have to add to 180 in a triangle. So all I have to do is take 180 minus 90 minus 60.9 to get that third angle. Okay, so you should get 29.1. Okay, either way, if you use the inverse or just subtract from 180 to get that third angle, you should get 29.1 degrees, or about that. Okay, so here I have it in order. First I found the side, then the angle, then the other angle. Okay, it doesn't always have to be in that order. If you know you have to find both angles and you solve for the angle first, fine. Okay? And then you solve for a side and then the other angle. It doesn't matter the order. That's just kind of how I do that one. So any questions? Just applying each thing that we've learned so far. Okay, I'm going to do one more. So we are still just solving this right triangle here. This one's a little bit different. So this time you're given two angles and one side. Okay, so I'm still finding all my angles and all my sides. So I need angle P, I need angle Q, and I need angle R. I need side PQ, I need side QR, and I need side PR. Okay, so you need all the angles, all the sides. So next what I always do is put the lengths I already know into my table. Okay, you should never get that wrong on a quiz or test. So PQ is 16. Angle Q is 90. And angle R is 33. Well, right off the bat, I can find angle P right away. Okay, just like we did before, I can just subtract the two I already know from 180. Okay, so 180 minus 90 minus 33, you do get 57. Okay, so angle P is 57 degrees. Now I need my other two sides of this right triangle. Okay, so I need this side over here, I'll label it P, and this side over here, I'll label it Q. Doesn't matter what you label them. Okay, you can label them X and Y, A and B, anything like that. So I'm going to use my trig ratios to solve for one of these sides. So I'm going to go from this angle 33 degrees since it was already printed on my triangle. And I'm going to solve for side P first. Okay, so I know this side of 16 is across from that angle. So that would be my opposite side. And the side of P that I'm looking for is next to my angle. So that would be adjacent. So if I have O and A, that would be tangent of the angle I'm going from, which is 33. So you put in that angle measure if you know what it is. Okay, that's equal to your ratio of sides. So O is 16 over A is P. Or A, you could keep it as A too. So now all we have to do is what we did yesterday. Okay, I'm solving for that variable within the ratio, so I always multiply by whatever's in the denominator. Okay, so I'll multiply both sides by P. So we have P times the tangent of 33 is equal to 16. What's my next step to get P by itself? Divide by tangent of 33. Good. Okay, so you can enter 16 divided by tangent of 33 into your calculator. And I got 24.6. Okay, and that side P was side QR. Okay, side that P was QR. So here I would have 24.6. All right, last side here, Q. You can do it two different ways. If you like trig ratios better, you can do it that way. If you want to use the Pythagorean theorem, since now you have two sides of your right triangle, you could do it that way as well. Okay, so it doesn't matter which way you do it. I'm just going to use the ratios just because that's what we've been working with. If you want to use the Pythagorean theorem and go ahead of me, that's fine. So here I'm going to go from my angle of 33 again because I already know what the opposite side is. And now I'm trying to find this side right here of Q. And that one would be labeled as H because it's the hypotenuse. Okay, so here now I have O and H, so that would be sine. So I'm going to use sine of that angle, which is 33. That'll be equal to that opposite side of 16 over the hypotenuse is Q. And again, when solving this type of problem, you already have the angle. You do not bring in the inverse. Okay, you only bring in the inverse if you have a variable attached to sine, cosine, and tangent. So I'm going to multiply both sides by Q. So I have Q times the sine of 33 is equal to 16. To get Q by itself, we divide both sides by sine of 33. And again, all you have to do is enter that into your calculator to get that side length. And you should get 29.4. Okay, so when you're solving, if you use the Pythagorean theorem, your rounding is going to be a little bit different than mine. Okay, your rounding will be a little bit different. It's like off by 1/10. That's okay. As long as you show work to show that you use the Pythagorean theorem, that's fine. So when you're solving a right triangle like this, you do need to apply all of those things that we've learned so far. Okay, so apply trig ratios, apply the inverse, and apply the Pythagorean theorem. So you have to kind of think about what you're missing and what you need to find. Any questions?